Hello and welcome back to another episode of Urban Informatics Over Coffee with Ellen. I'm Ellen, and today is part 3 of turning your OSM data into a CSV or an XLSX format. So grab your coffee, grab your comfy chair, and let's dive right in. So we left off from the last video with a lot of non-usable data in an Excel spreadsheet. I have each polygon from that copying and pasting into the same sheet, but I have now ordered it according to name, so it's in alphabetical order according to name. So all the similar polygons will be next to each other. So this polygon, which is a line string for some reason, has 2 levels, is semi-detached and post 2000. So we got all that from the past 2 videos of working through all those steps. Now, I'm not here to teach you how to Excel, so I'm going to glance over how you get all these into the same row against the same polygon. You can do it manually, that'll take a really long time. But here I have some fancy formulas up the top here, which did it automatically for me. So no matter how you get your data to work for you, to have all the information against the same polygon, do that, and then we'll skip to the next thing. So use ChatGPT, they can write you some Excel formulas, or use, call a friend, or use your own brain, however you like. But you see here, this would be the final product. I have a polygon, I have how many levels it has, I have what type it is, so house, semi-detached or apartment, and I have its age as post or pre-2000. And the reason I have an extra column here was dwelling count, was for the apartments that came up as one building, but it had 8 units in it. So I took all those apartment units and I copy and pasted it again down the bottom. So some of these polygons reappear twice, but it doesn't really matter that much anymore. So all the apartments are in here, the amount of units it has, to get me an accurate dwelling count without having to worry about this extra row of information. And you can see I have 1,707 different polygons or different buildings that I'm looking to collect data from. So that's a lot. That would have taken a lot of time to do manually. So once I've extracted all this raw data, I have a new spreadsheet, and I apologize that it's not very aesthetic to look at. I was just doing what I could to get the numbers out. So what I've done here is I've used ABS data. So this is just a sheet with all the raw ABS data in terms of Thomastown. And what I particularly got out of the ABS data was how much of the percentage of the population is, a family unit, or they live alone, or they're a uni student, or they're over the age of 60, whatever I was interested in looking at in terms of finding out what is the appropriate housing for them. So if we go back to our housing analysis, I have picked out 60 plus age, the household's a family, a lone person is a share house, the person's attending university, couple without children, couple family with children, or one parent family. This column here next to that is the percentage of the population of Thomastown that is that thing. So this won't add up to 100%, there will be some overlap, but there is 26% attending university, and there's 27.5% that are over 60. So I've broken down the data here. So we have 3 categories. We have house, semi-detached apartments, level 1, 2, and then pre and post as the age. So there's a total of 1,748 dwellings, using some simple formulas to count for me. From that 1,748, I have 1,225 houses or detached houses, 472 semi-detached, and 51 apartments. So that's the individual units, not just the building. And then next to it is the percentage. And then next to that as well is the ABS standard for the state. So you see Thomastown is roughly 15% less than the ABS standard for how many houses makes up the total housing stock. And I did the same for that, except there's no data for levels 1 and 2 in the ABS. So 86% level 1, 13% level 2, 79% was built pre-2000 and 20% was built after the year 2000. So we can break that down again, but what we're going to look at now is this. This is what's important. So I've broken down house here as a one level pre-2000, how many of those are, and there is 1,117 of those, which is 63 or 64% of the entire study area, which is quite high. And then it's broken down again into 1-story post 2000 and then 2-story pre, 2-story post, and I've done that for each of the types. So all these percentages will equal 100% of the study area. So from the existing supply, if I use age group 60 plus, I might zoom in, 30% of the population is over the age of 60, but from the study area, only 10% of it is suitable for that age group. And how I work that out is adding up what is the suitable type of housing. We're only interested in small for the elderly, so there's not too much to look after and there's no apartments, so it's just semi-detached. We're also only interested in 1-story because as you get older, stairs get harder, and we're only interested again in housing that is built post 2000. The housing stock from all those is just 10%. If we look at the opposite, we can see a family composition, 97% of the existing housing is suitable. So if we look at what I've pretty much pulled everything except apartments, which is 97% of the housing stock. A family composition is very broad. You could have a 3-person family, you could have a 6-person family. So without knowing the amount of bedrooms in these houses, I have just pulled everything, and 97% is suitable. This next column here is a deficit, which is based off what is the difference between the percentage of the population and the percentage of the suitable housing. So you can see with age 60 plus, there is a difference of 17.49%, which is quite significant. There is also a few deficits down here for a couple without children and attending university. And of course, there's plenty of positive because surplus of that one type of house. So that's how we looked at that analysis. And from here, you can manipulate this to get a different outcome. So if I look at this housing tab, which looks very similar, and again, not very aesthetic, I have changed the total of the housing supply to be plus existing, plus whatever the net increase was with a certain proposal. So we now have a new number, which these percentages will be based off. And I've added, as you can see, here's the obvious one, there's now 350 apartments. And we've pulled those numbers again, which I've added here. So from this new calculation and the new numbers, we have a new proposed suitable housing percentage for the study area. And as you can see, age 60 plus has gone from 10% to 29%, which is just over the population, and there are currently no deficits in this number. You couldn't have done this sort of analysis using Mapbox or using visualizations. You just needed to count, do some number counting to see if what you are doing is achieving what you set out to do, and that is to fix the housing gaps in the study area. And then from here as well, you can turn this into much more user-friendly information. As you can see, I've just created some 2 basic graphs in Excel to say this is the proposed suitable housing stock and this is the existing suitable housing stock. And then you can edit these graphs to your heart's content. You can even put them on the same graph. You can do whatever you want. It's up to you. But this is why we were looking at getting our spatial information as a CSV file so we can do this level of analysis. This video wasn't too much of technical showing you how to do something, but showing you the idea of what you could do once you got your information in an Excel format, and really have something that's concrete, saying this is the existing condition and this is the improved proposed condition that the design or the project will have on it. It was quite a lengthy process to get to this point, and there was lots of trial and error, but hopefully these videos have made this easier for you if this is something you wanted to achieve. So thank you once again. Go out and enjoy all the coffee that you can in the meantime, and we'll meet again in the next video to discuss more urban informatics over coffee.